Hello, my name is Trey. Today we'll be looking at electric potential difference on this circuit. Let's go ahead and get started, and I'll explain real quick what we got here. We have a 12 volt DC source. In parallel we have a 1000 ohm resistor, a 10 microfarad capacitor, and a 620 ohm resistor. Also, you'll notice in kind of a pink color we have voltmeters attached. 1, 2, 3, and 4, and what we're trying to do is figure out or predict what these voltmeters should read mathematically. So let's go ahead and get started. I'm going to go ahead first write down what the equation is for potential difference. It's delta V equals VA minus VB. A and B are just points along the circuit, so that equation we're going to have that. The other thing we're going to need is a ground. I'm just going to stick it right here. This is dealer's choice. You can put a ground wherever you want, and you can put the ground anywhere along here. It's okay to do. I just chose to put it under the source. It's kind of a standard or normal thing that people do. What's it mean to be ground? It means that any conductive material that is somehow connected to ground, so everything here and here and here all has a potential of 0 volts. So I'm just going to mark that just like this in green. That's going to have a 0 volt potential. Now let's talk about the circuit above that. What do we see here? Well, if we know that the current should be traveling in this direction. If we start at ground, where we're at 0 volt potential, cross through the battery, we should jump by 12 volts. So everything here, I'm just going to mark it in blue, should have a 12 volt potential. Now it becomes to read these meters or predict what these meters are going to read is pretty straightforward. So let's look at the oops, got the wrong color. Let's look at V1. What do we have for V1? Well, for V1 we are hooked here and here. So we have a 12 volt potential and a 0 volt potential. Take the difference. Oops, there we go. That's 12 volts. Let's look at V2. V2 I think is going to have a similar situation. V2 is connected here at 12 volts and here at 0. So I should get 12 minus 0 or 12 volts. And then V3, what's that going to look like? I think you're probably starting to get the idea here. We're connected here at 12 and here at 0. So again, it's 12 minus 0, oops, or 12 volts. And then meter 4. Now this one might be a little tricky. We're connected here at 12 and again over here at 12. Well, we just take the difference. 12 minus 12, or 0 volts. So there you have it. A fairly straightforward circuit. Easy enough to predict what the voltmeters are going to read. Now obviously when you read a voltmeter, it's going to have a little bit of a difference. It's not going to be exact, but it'll be fairly close. So anyway, if you have any comments or concerns, put them below, and if you could please mark like for this video and subscribe to my channel, that'd be great. Have a good one.